Thank you for joining me today. I'm going to be talking to you about multiplying decimals. A couple things we want to cover before we get started. Some terminology I might be using. First of all, one of the words is evaluate. This is simply to find the value of an algebraic or numerical expression. A lot of times we'll just say go solve it. Well, sometimes they'll also say evaluate. So it's just a different word that we may use in math to say solve. Expression, a mathematical phrase that contains numbers, operations, and or variables. Okay, and you'll notice that we use and or because it doesn't have to, but it can. So an expression can technically be all numbers with operations, or it can actually involve some variables as well. And you'll actually see an example where we do that today. And then lastly, product. Because we're multiplying, we need you to know the technical or mathematical term for the solution or answer to a multiplication problem. That would be product. A lot of times they'll use that. It's more of a fancier term than just to say what's the answer. We want to know that we're getting the answer to a multiplication problem. So we'll say what's the product. So let's take a look at some examples of how to multiply some decimals out. Here's just some two-digit decimals, 2.5 times 3.2. Now, on another lesson, when you do addition and subtraction, you typically have to line up your decimals. Well, with multiplication, that's not the case. You can see down here at the bottom, I've noted in red that you do not have to line up the decimals, so don't worry about that. You're technically going to probably line these up anyway, but in the case that you're dealing with numbers or decimals that are not of the same length, then you may struggle because you think you have to line them up, and you don't. So we can just write these as 2.5 and 3.2 and prepare to multiply. All right, and multiplying decimals is no different than multiplying any other numbers, 2-digit, 3-digit, whatever. You're going to start in the lower right-hand corner down here with the 2. And one thing I neglected to mention earlier is it doesn't matter if you put 3.2 on top or if you put 2.5 on top. Either way, I just decided to do 2.5 on top. So here we go. We're going to start with the 2 in the lower hand corner here. 2 times 5 is 10, which means we need to carry the 1 over above the 2. Now we'll do 2 times 2 across. So that's going to give us 4 plus 1 is 5. Right? So for our second part, we need to hold the place. I always hold the place with a 0. And then we'll start multiplying from our tens place. So that's with the 3. So 3 times 5 is 15. Carry the 1. All right. If you like to scratch that first one out and write another one, you can. And then 3 times 2, directly above. 3 times 2 is 6, plus 1 is 7. And then we go ahead and add those up. So we get 0, 5 and 5 is 10, carry your 1, and you end up with 8. Now before you're finished with the problem, you need to make sure that you pay attention to how many places you need to move the decimal. We don't just stop here and say that 2.5 times 3.2 is 800, because that's not true. That's like saying 2 times 3 is 600. It's not true. So if we were estimating here 2.5 and 3.2, that gives us a rough estimate of where we should be close to. 2 times 3 is 6, so we should be near 6, so 800 doesn't make a whole lot of sense here. So notice that we have two numbers here that are behind the decimal. We have a 2 and a 5. Both of these numbers are behind the decimal, one place. So you count up the total values that are behind the decimal or to the right of the decimal, and that's how many times you need to move the decimal in your solution. So notice we have a 5 and a 2, two numbers. So we're actually going to move our decimal, which would be at the end of our number, 800, 2 places to the left. And it's always to the left in this case. So you're going to end up with 8 as your answer. Now, does that make more sense? Yes, because if we were just simply estimating here, we would say that this is 2.5 is approximately 3, and 3.2 is approximately 3. So we should be somewhere around 9, and that's exactly where we're at. We're right near 8, or we're right at 8, excuse me. We're going to carry the 2. We're going to do 5 times 8, which is 40. Add the 2, which gives us 42. Carry the 4. 5 times 3 is 15, plus 4 is 19. Hold the place now with a 0, and we'll go through and multiply all those same numbers with 1. 1 times 5 is 5. 1 times 8 is 8. And then 1 times 3 is 3. Now we add. So we end up with 5 and 0 is 5. 2 plus 5 is 7. All right, 9 plus 8 is 17. We're going to carry the 1 there, which gives us 2 plus 3, or 5. All right, so again, down here at the bottom, you'll notice it says before the problem is complete, you must move your decimal the correct number of places. So to determine that, again, look at how many numbers are to the right of your decimal in your original two numbers. So here we have 3.85 and we have 0.15. Those are the numbers I'm talking about. How many numbers in each of those are to the right of the decimal? Well, notice you have 8.5 here and you have 1.5 here. All of those, 4 of them that are to the right of the decimals. So all of those in total, which is 4 places, will be how many places we move our decimal. So our decimal originally is at the end of our number. We haven't moved it yet. So right now we're looking at an answer of 5,775. But again, if we use estimation, that doesn't make a whole lot of sense because 3 is approximately 4 and 0.15, well, is approximately 0. So our answer should be somewhere around 0. Okay? Well, 5,775 is not near 0. So we need to move our decimal 4 places. 1, 2, 3, 4. And what that means is we end up with a decimal of 0.5775, which is below 1, or pretty close to 0. But again, if we use estimation, that doesn't make a whole lot of sense because 3 is approximately 4, and 0.15, well, is approximately 0. So our answer should be somewhere around 0. Okay? Well, 5,775 is not near 0. So we need to move our decimal 4 places. 1, 2, 3, 4. And what that means is we end up with a decimal of 0.5775, which is below 1, or pretty close to 0. All right, this is technically what we call evaluating an expression. Right? You'll see that we have a variable here in x, and that variable they want you to substitute in 3.6 for that variable. And we say substitute it because what they want you to do is to take 3.6 and put it in for the x. Now down at the bottom, notice that I put here that when a number is directly next to a variable in an expression, it means to multiply. So what this means is 2 times x. Right? And actually, because we're using the variable x, I'm going to use 2 times x, which is a little point that they'll also use for a multiplication sign at times. Usually they use that when we're using variables, such as x, so you don't confuse the multiplication sign with the variable. So don't just plug that in and think that you're going to end up with 23.6. That's not what they're asking you to do. All right, so the first thing we need to do is let's write out the problem as it would be if we go ahead and substitute that in, and that's going to be 2. And when I substitute in a value, I'm going to use parentheses to separate what I've substituted in the what we call a coefficient, or the number in front of the variable, which is 2. Okay, I'm separating them with parentheses. This still means to multiply. If you haven't learned that yet, when a number is directly next to a parentheses like this, that means you need to multiply. All right, so there's what our problem is. We need to go ahead and find and evaluate. So 2 times 3.6 we can do off to the side here. Again, put the largest of the decimal values or values on top, or the one with the larger amount of numbers on top. So that would put 3.6 over 2, because 2 only has one digit. And we'll multiply. 2 times 6 is 12. Carry your 1. 2 times 3 is 6, plus 1 is 7. So how many values do we have that are on the right side of a decimal? We only have 1. So we need to move our decimal one place to the left, always to the left, and we see that we get 7.2. Right, we're not quite done yet though, because they want us to take and add on 5. So this kind of takes you back to your addition of decimals, where you do actually have to line up. This is kind of a combination problem. So we're going to take 7.2 and add it to 5, making sure that we line up our decimals. Notice I've lined them up right here. Okay, 5 in the original problem doesn't have a decimal, but it technically is directly at the end of the value right there. So when we do this addition, we have to make sure to compensate for that and put it into the problem and line it up. So we're going to add now. 7.2 plus 5. 2 plus 0 is 2. Bring your decimal straight down. And 7 plus 5 is 12. So you end up with 12.2 as your solution there. All right, little two-step problem. So how will they incorporate this into word problems? Well, many different ways. Some of the more popular ways will be things, again, like miles per gallon, or finding how much you might spend on gas, such as this problem here. If I bought gas for $3.29 a gallon, if I need 12.5 gallons to fill up my tank, how much will I end up spending? Well, that's kind of an important thing to know. You want to know how much it's going to end up costing. So you're actually going to take, in this case, 3.29 and multiply it by 12.5. And again, notice I'm not worried about lining up my decimals here. Just go ahead and technically, because they both are 3-digit values or 3-digit numbers, you can put either one of them on top. It really doesn't matter. So we're going to go ahead and now multiply. 5 times 9 is 45. Carry the 4. 5 times 2 is 10, plus 4 is 14. Carry the 1. 5 times 3 is 15, plus 1 is 16. Hold the place with a 0. Now we move to the 2, and we go ahead and multiply all the digits in 3.29 again. 2 times 9 is 18. Carry the 1. 2 times 2 is 4, plus 1 is 5. And then 2 times 3 is 6. All right, we haven't had to do more than 3 times in a multiplication as of yet, but you do have to hold an extra place again. We're moving into what we call the hundreds place. We held the place for the ones, we hold the place for the tens, now we're multiplying with the hundreds. So we're going to multiply everything by 1. 1 times 9 is 9, 1 times 2 is 2, and 1 times 3 is 3. And just be sure to keep everything lined up. You can see in my problem that all of my columns are lined up. You try to keep everything organized. You'd be amazed how much that helps. So we know 5 and 0 is 5. 4 plus 8 plus 0 is going to be 12. We need to carry a 1 there. 6 plus 1 is 7. 7 plus 5 is 12. And 12 plus 9 is 21. Again, if you're not sure about that addition, because I know I did that kind of fast, you need to go off to the side and go ahead and add everything up. But an easy way is to look for compatible numbers that create 10. So notice in that column you have 9 and 1. Well, 9 and 1 is 10. So 10 plus 5 is 15. Then 15 plus 6 is 21. Try to make it easier on yourself. In this case, since we got into the 20s, we have to carry a 2. So 2 plus 1 is 3. 3 plus 6 is 9. 9 plus 2 is 11. Carry the 1 again, and 3 plus 1 is 4. So we're not quite done though, because I'm definitely not spending $41,125 on gas. So I need to figure out how many places to move my decimal. So notice that in the first number, 3.29, that there's 2 values behind the decimal, and in the second number there's only 1. So that's a total of 3 decimal places that I need to move my decimal. And again, the decimal is always at the end of the number. So I'm going to move it in 1, 2, 3 places. And what you end up with is 41.125. Well, as we know that money in our system only goes out to 2 decimal places. So we will round, okay? We'll make our rounding based off of that last digit in the thousandth place. If that number is 5 or greater, we round up. If it's 4 or lower, we round down. So in this case, since it's a 5, we're going to round that 2 to a 3. And I will be spending $41.13 on gas. All right. And one more example here. We're talking about spending some money on sliced ham, $2.50 a pound. And if I want to purchase 3.6 pounds, how much will that cost? Well, let's take a look. We're just going to use multiplication there. One of the words in these types of problems that give that away is if he wants to purchase 3.7, let's see, the local sandwich shop charges $2.50 a pound. Sometimes they will use a pound, or sometimes they will use per pound. That word a and per in this case will always denote multiplication. So in this case, they just used a. So $2.50 times 3.6. Notice how I put the one with the most digits in it on top, the one with the lower number on the bottom. And now we're ready to multiply. 6 times 0 is 0. 6 times 5 is 30. Carry the 3. 6 times 2 is 12, plus 3 is 15. Hold the place with a 0. 3 times 0 is 0. 3 times 5 is 15. Carry the 1. And 3 times 2 is 6, plus 1 is 7. And we're adding here. 5 and 5 is 10. Carry the 1. 7 plus 1 is 8, plus 1 more is 9. So again, I'm not spending $9,000. We need to figure out how many places to move the decimal. So if you look at our original decimals here, there's 2 digits in 250, and there's 1 digit after the decimal. Again, that's what we're looking for. How many numbers are after the decimals? So there's 2 in the first decimal and there's 1 in the second. So that's a total of 3 places. So that's going to be 1, 2, 3 places. So it looks like I'm going to end up spending $9. All right. This has been a quick tutorial on multiplying decimals. Thank you for joining me.